The objective for this video is to learn how to find the test value for a chi-square test for independence. In a previous video, we learned how to find the critical value for a chi-square test for independence, where we were testing whether academic achievement is independent of number of hours spent weekly working part-time. If our calculated chi-square test value is greater than this critical value of 9.488, we should reject the null hypothesis. We will now calculate the expected values for each cell in the contingency table. We will do this by first dividing the sum of each row by the grand total, and then multiplying that by the sum of each column. So we will need to augment this table with totals for the rows and for the columns. The expected value for the cell that is positioned in row 1, column 1, will be found by dividing the sum of row 1, 97, by the grand total, 200, and then multiplying that by the sum of column 1. So the expected value for those who work less than 11 hours per week and indicated on the survey a positive effect is equal to 16.975. Likewise, the expected value for row 2, column 1, will be 11.2. We will continue this process until we arrive at the cell that is positioned in row 3 and column 3. We find that expected value to be 11.7. Our contingency table now contains expected and observed values for each cell in the table. Step 3 is to calculate the test value. The chi-square test value is calculated by subtracting the expected value from the observed value in each cell, squaring that difference, dividing it by the expected value for that cell, and then adding that quantity for each cell. If the observed values and expected values are not significantly different, then this sum will remain small. However, if the observed values and expected values in each cell differ significantly, then this sum will become large. If this sum exceeds the critical value, then we should reject the null hypothesis. So we will begin by finding the difference between the observed and expected values in row 1, column 1. Then square that difference, then divide by the expected value, and then continue that process down to the last cell. We find our test value to be 13.938. So with a chi-square test value of 13.938 and a critical value of 9.488, we can complete step 4, which is to make a decision. Since the chi-square test value is greater than the critical value, we should reject the null hypothesis. Step 5 is to draw a conclusion. Since we rejected the null hypothesis, we will conclude that academic achievement is dependent on the number of hours worked. In this video, we learned how to find the test value for a chi-square test for independence.